Sorry guys, I didn't mean to get caught off on the last video. I didn't realize I was at the 15-minute mark. I was saying this is where f of x changes from negative to positive. That's why we have the minimum there. Okay. C says, what is the minimum number of points of inflection that exist on f of x, and where do these occur? So what we have to remember is, where do our points of inflection come from? Okay. Well, our points of inflection are where the second derivative equals 0. Okay, and the signs have to change. So we're looking where the second derivatives are equal to 0 here. So that is when x is negative 3, here when x is negative 1, and here when x is positive 3. Okay, and you'll see that yes, the sign does change from negative to positive to negative to positive. So I know that at all three of those points, those would be points of inflection. Okay, so my good justification would be that f double prime of x is 0 and it changes signs. Okay. All right, so that's it for the numerically, looking at it from a table. Now let's look at it from a graph. This is what we did on Monday in class. So here I've got my function, and this says that this is f prime of x. So remember, this is the derivative that we're looking at. We're not looking at the original. Okay, it says the figure above shows the graph of f prime, the derivative of the function f for negative 7 less than or equal to x less than or equal to 7. So that means it's a closed interval from negative 7 to 7. The graph of the derivative has horizontal tangents at negative 3, 2, and 5, and a vertical tangent at 3. Okay, so what we're looking for here is the information that it's asking. It's saying on the open interval, find the x's where the function, not the derivative, where the function attains a relative minimum. Okay, so what we have to remember with a relative minimum, it comes from where the derivative equals 0 and how the sign has to change. So what we're looking for is, first off, where our derivative is 0. So our derivative is 0, okay, at my x-intercepts. All right, so if we want the minimum is going to be where it changes from negative to positive. So this means where my function is going to change from my y values being negative to my y values being positive. So here, these y values are positive above the graph, and these y values are negative below the graph. So that means this point right here is actually going to be a maximum. Then we go from negative, and now my y values are positive. So this one right here will be a minimum. So when x is negative 1, okay, and that's because the derivative there is 0, and the sign changes okay, from negative to positive. Okay, this one over here, it's positive and then positive, so that's not going to be a max or a min. Okay, so something else is going on right there. Okay, so part B says find all values of x on the open interval where the function attains a relative maximum. So we kind of just answered that one. So we knew that this was going to be something, and it's going to be a maximum because it's going from positive to negative. So when x is negative 5, and because the derivative at negative 5 is 0, and the signs change from positive to negative, okay, or the function's going from above to below, if that helps. Okay, and then the last part here says find all values of x on the open interval at which the second derivative is less than 0. Okay, so this is going to be where we have concave down Okay, so what we're looking for here is where the slope of the derivative where the slope of the derivative is negative. That would give me concave down. So that is going to be from -7 to -5. It is also going to be from 2 to, let's call that 3 right there. So from here to here. Looks like a point of inflection. Okay. And then from here, no, still, this is still concave down. So, and then from 3 to 5. I'm sorry. Yeah, because that's still where our slope is negative. Okay. This piece here has a positive slope, so it's not counted. This piece has a positive slope, so it's not counted. So we've got 3 here, okay, that would give us concave down because the derivative has a negative slope. Okay. Hope that helps. You guys have a quizzes homework to go and do, so please make sure that you go and do that. And hopefully we'll see you in class. Bye.